So let's take a look at this part A here first. If you think of these, each individual term as a fraction, okay, what you can see is your LCD, you have a 1, 1, x, x. Okay, so you really only have a single factor for your LCD. So this is the type of problem where that second method is really efficient. If you take the LCD, which is just, again, a 1, 1, x, x. So here's your LCD. You multiply that over itself. And if you just work in the numerator to start with and distribute this across, you get an x squared plus 1x minus 6. And that's all over here when you, in the denominator, when you distribute or multiply through, the x's cancel and you're just left with the 1. So in looking at this, you can write this in the factored form. The two factors of negative 6 whose sum is plus 1 is an x plus 3 and an x minus 2. Okay, and that is your solution. Okay, now, you do need to, if you're going to use this method, go back to the original form to look for any domain restrictions. So you see here that x can't be a 0. That's not apparent in the simplified form, so you'd have to do it independently in this form. Okay, but you can see that this is the case where that LCD method of solving works pretty efficiently. If you were going to solve this the other method, where you rewrite the numerator as a single fraction, your LCD would be x, and then you take your first fraction's numerator, x, times the missing LCD factor, times another x, plus your next fraction's numerator, 1, times the missing LCD factor, x, minus the next fraction's numerator, 6, times the missing LCD factor, it's not missing anything. And then you divide this whole thing by 1 over x, which means you invert and multiply. This becomes multiplied by x over 1. Here the x's cancel, and you get the exact same